Now we will discuss about types of constant motion in a kinematic pair. So there are generally three types of constant motion. One is completely constant motion, unconstrained motion, successfully constrained motion. So first we will see what do you mean by completely constrained motion. So when the motion between a pair is limited to a definite direction, irrespective of the direction of force applied, then the motion is said to be a completely constrained motion. For example, the motion of square bar in a square hole. Here we can see the completely constrained motion. The first picture, that is, here we are having a square bar inside a square hole. So that square bar can only move in one direction, that is the sliding motion, or we can say in linear direction. So this is a completely constrained motion kinematic pair. Then in the second picture also we can see a cylindrical shaft is inside a cylindrical hole, but we have abstracted the motion, linear motion from two sides, so that this cylindrical shaft can only be rotated or turned inside the cylindrical hole. So this is also a completely constrained motion. So second one is your unconstrained pair, or we can say incompletely constrained motion. When the motion between a pair can take place in more than one direction, then the motion is called as incompletely constrained motion or unconstrained motion. Here in this third diagram, we can see there is a cylindrical shaft and a cylindrical hole. So this shaft can also slide inside this hole, and also it can rotate in clockwise or anti-clockwise direction. So various type of motion is possible between this shaft and this hole. So this is incompletely constrained motion, or we can say this is unconstrained pair. Then in third we will see the successfully constrained motion. The motion is said to be successfully constrained when the motion between the elements forming a pair is such that constrained motion is not completed by itself but by some means. Means some external force will be applied to make a unconstrained pair into a constrained pair or completely constrained pair. So in this fourth diagram we can see one shaft is there inside a footstep bearing. So this shaft can also be moved upward and downward, means linear motion is possible here, and this shaft can also rotate it clockwise and anti-clockwise, means rotational motion is also possible. Means initially this is a unconstrained pair, but when we will apply some load on the shaft from the upward direction, then the linear motion can be restricted. So only the rotational motion is possible. So we are making this one into a constrained motion. So if we will apply some force to make an unconstrained pair into a constrained pair, then we will call it as a successfully constrained pair. Next we will see the inversion of mechanisms. So first we will discuss what do we mean by inversion. So inversion means the method of obtaining different mechanisms by fixing different links in a kinematic chain is known as inversion of the mechanism. Means suppose the number of links in a mechanism is 4, then maximum 4 number of inversion can be possible by fixing one link at a time. So types of kinematic chain. We have generally 3 types of kinematic chain. What is we are studying, that is 4-bar mechanism or 4-bar chain, slider crank chain, then double crank chain. So first we will discuss about the inversion of 4-bar chain. So inversion inversion of 4-bar chain has 3 inversions. That is first inversion, second inversion and third inversion. In first inversion, we will study about beam engine. Then in second inversion, we will study about coupling rod of locomotive. Then in third inversion, we will study about watt indicator mechanism and pantograph. In third inversion, we will study about two things. This is beam engine. So here we can see we have 4 links are there. The link number 1, that is the fixed link, this stand and the cylinder. Then link number 2 is the crank. Link number 3 is the connecting rod, which is connecting the crank and the oscillating member. And the oscillating member is the link number 4. When the crank rotates about the fixed center, the lever oscillates about a fixed center. The end of the lever is connected to a piston rod which reciprocates due to the rotation of the crank. In other words, the purpose of this mechanism is to convert the rotary motion into reciprocating motion. What we can see here. Here this stand is fixed, then a crank is fixed to the stand, that is link number 2. Then a connecting rod is connected to the crank, which is transferring the rotary motion of this crank into the oscillating member, that is link number 4. Then coupling rod of locomotive. Here also we can see the 4 bars. That is the back side bar, that is link number 1. Then 2 cranks are there, link number 2 and link number 4. And both the cranks are connected by 1 bar, that is link number 3. It is a double crank mechanism. In this mechanism, the link AD and BC having equal lengths act as crank and are connected to the respective wheels. The link CD acts as a coupling rod and the link AB is fixed in order to maintain a constant center to center distance between them. This mechanism is meant for transmitting rotary motion from one wheel to the another wheel.